Hi, everybody. So this is the next section. If you've watched the multiplication with fractions video, this is the next one. Just try to, come on, dude. This thing is not focusing. Here we go. Okay, so first, I wanted to ask the following question is, what is a reciprocal? I mean, we use it all the time, and we kind of know what it is already, most of us, but why did we define it that way? And so let's just quickly talk about it so we never forget it. Okay, so let's suppose I have 2/3 times 3/2, and then I'm going to also multiply 2/5 times 5/2, and I'm going to multiply 3/4 times 4/3. Recall our multiplication properties, right? So when we multiply, we just went over multiplication with fractions. And remember, you take the numerator and the denominator, and since this is equal to itself, we get 1. And we're going to start seeing a pattern, right? This is also one way to cancel out. Get 1 over 1, which is 1. Give me a second, I'm sorry, it's all focused. Do it this way. Okay. 1 over 1, which is 1, and then we get 3/4, which is 3 times 4, which is 12, over 4 times 3, which is 12, and that's also 1. And so observe that what do you notice about these numbers is basically that for every fraction, there's another, this number has a special property in that if you multiply this fraction by this specific one, you get 1, okay? And it's its inverse. It's called the multiplicative inverse, right? And this is the multiplicative identity. So if we were to create a rule, in general, remember if I had a whole number, let's just say random whole number, and I wanted to find its inverse or its reciprocal, what would I do? So recall that we could write this as a over 1, right? Then if I multiplied this by 1 over a, I would get a over a, which is also 1, right? Because these cancel. This is the general form of the reciprocal. So it brings us to definition, also known as multiplicative inverse in some circles. Is for any number a, the reciprocal can be considered 1 over a. Okay. So sometimes people write it as a to the negative 1, which is the same thing. Okay. Another way of saying the same thing. Okay, so let's list some reciprocals, right? Let's do more. So list the reciprocal of 3/2. We listed that already. Oops. 1/7, 6/7, and 2,348 over 5,719. Just a joke. And can you tell me the reciprocal of circle over triangle? I mean square. This is not 0. This is a circle. Or maybe I'll just make it a happy face. Okay, great. So the reciprocal of 3/2 would be 2/3. The reciprocal of 1/7 would be 7 over 1, or just 1, or just 7. The reciprocal of 6 over 7 would be 7 over 6. And then you get the idea, right? And then this would be, of course, square over happy face. This is happy face. Okay, great. Okay, so those are some examples of reciprocals. So now that we're fully aware of what the term reciprocal means, we spent the last 5 minutes on this, let's go ahead and talk about dividing. Okay. So the property of division is if you have a dividing with fractions, so you have numbers A, B, C, and D, such that B, C, and D are not equal to 0, then you can say that the fraction AB, or the rational number divided by CD, can be expressed as A over B times D over C. Okay? So when we divide two fractions, we can also think of it as multiplying by its reciprocal. Okay? So let's do an example. So divide 1/2 by 1/4. Okay. So if I wanted to do this, I would take 1/2 and then take the reciprocal, which is 4 over 1, and then I would just do like how I've been doing, right? Since the last section, 1 times 4 over 2 times 1. I don't have to write this every time. At some point, I'm just going to start noticing, oh, that's just 2, that's just 3. So the more you practice, the easier it will become. Okay, let's do another one. Divide 3/8 by 9/4. Sure, okay. So let's go ahead and we take the first one and we find the reciprocal of the second fraction and we simplify. 4 times 9, and that's going to be, either you can do 12 over 72, which reduces to 1 over 6. Okay. All right, so now you try. Okay, and since I'm not physically in front of you, I can't sit and stare and watch at you while you try. So honor system is that you are going to pause this video. Okay, you're going to pause this and you're going to try these first, okay, before you see me work them out. Try these first on your own. Trust me, this is good for you. This is good for you. And then after trying them, even if you don't get them correct, just write something down. We'll go back and we'll go over all of them, okay? So I want to see that you are trying them. This is a 35. And let's do 27 divided by 3. Okay, great. So, sorry, it doesn't look very neat. This is a division. Okay, so go ahead and pause this. Okay, and go ahead and try. Okay, I am going to assume that you went ahead and tried these. So let's see what we get. So remember that you could write this as 2/3, sorry, I wrote this first, divided by 2 over 1, right? We can write any whole number as a fraction. So that makes it easy to find the reciprocal of it. Okay, and that's just 1/3. Okay, so similar for the others, we would rewrite this as 2 over 1, and then divide by 1/3, which is just 2 over 1 times 3 over 1. Well, that's just 6, right? Over 1. Okay, so then this next one, you would get 4 over 27 times 9 over 16. Okay, and then we observe the following. 4 goes into itself here once, here 4 times. 9 goes into itself once, here 3 times. 1 times 1 is 1, and 3 times 4 is 12. For this next one, 16 35ths times 1 over 8 is going to become 16 over 8 times 35. But then observe that 16 is equal to 8 times 2. So 8 goes into itself here, 8 goes into here twice, so your answer is just 2 over 35. Okay. And then last one, 27 times 2/3, right? So 27 over 1, right? We can say 3 goes into itself once, 3 goes into here 9 times, 9 times 2 is 18 on the top, and 1 times 1 is 1, so my answer is just 18. Okay? So give yourself a pat on the back if you got it correctly. And if not, you can always email me, or we can talk about it in our next class. Okay, I think we're ready to start some homework.